So in lesson 13.2, you learned about the unit circle where everything is learned in degrees, and I talked about how we can use the unit circle to find the sine and cosine of an angle. Well, you're usually used to seeing angles in degrees, but actually angles are not only in degrees. There is another degree measure called radian. And radian, usually when we talk about radian, there is some, most of the time we describe it with some kind of pi in there, but pi itself is not radian. Okay, so pi is not a unit. You don't write 3 pi thinking pi is radian. So anyways, we'll get more into that later. Okay, so to convert from degree to radian, we multiply by pi over 180 degrees. So what you need to do is think about a circle. So a circle is 360 degrees. And so half of a circle is 180 degrees. Now a whole circle is also 2 pi in measurement. So that's like all the way around. It's 2 pi in measurement. So then half of a circle is pi. So basically we're saying that pi is the same as 180 degrees. And so this is the unit conversion factor. Okay, let's look at an example. Convert 30 degrees into radian. So what you do is you take 30 degrees, you multiply by the conversion factor, which is pi over 180. And then you just try to simplify as much as possible. So this is going to simplify to 6. So 30 degrees is actually pi over 6. Okay, pretty easy. You just need to remember that pi just means 180 degrees. And then you can use the unit conversion factor the way you want to. Okay, now let's say that we want to go backwards. We want to change from radian to degree. Okay, to change from radian to degree, we want to multiply by the opposite. So that is 180 degrees over pi. Okay, so let's look at this one. 5 pi over 4, 2 degrees. Okay, so what you do is you take 5 pi over 4 times 180 degrees over pi. And then you want to cross cancel as much as possible. So you can see that the pi's cancel. 4 and 180 cancels. It becomes 45. Okay, and then 45 times 5 is 225. Okay, so that is 225 degrees. Okay, pretty easy to kind of change back and forth. You just need to remember 180 degrees and pi mean the same thing because it's half of a circle. Okay, so now what I want you to do is go back to 13.2 and then fill in the rest of the unit circle. So I have another blank one here, but you had everything filled out. For example, you had like 0 degrees and 30, 45, 60, all that stuff. And then you had 1 0 here. This was square root 3 over 2 1/2, square root 2 over 2, square root 2 over 2, and you had 1/2 square root 3 over 2, and so on, right? So the only thing missing is, I don't know if you noticed, there's this one spot here. That is for the radian. So what I want you to do is go back and fill it all in with radian. So now you have your whole entire unit circle all filled out. So I'm going to kind of help you with some of the easy ones. So this is 0. This next one we already did, pi over 6. 45 degrees. If you're not sure, so 45 degrees, we don't really know what it is in radian right now. So we're going to multiply by the conversion factor, which is this one. And then so what we want to do is just simplify this. Now what you don't want to do is you don't want to put it in your calculator like this and then get like a decimal amount, because that's not what we're looking for. We're not looking for a decimal. What you want to do is actually just simplify the fraction. So put it in your calculator, let your calculator simplify for you, or if you know how to simplify it really quickly, you can do that. So you want to just cross cancel and simplify. This is going to turn out to be pi over 4. Okay, so again, you want to leave it in fraction. Do not change anything to decimal. So pause this video, I'll give you a few minutes to fill it all out. That gives you a chance to practice how to change this to radian, and then come back and check your answers. Okay, so hopefully you got all of them right. Now the question is, how are you going to memorize all these? First, you need to try to memorize how the degrees link up with the radian. So try to see some patterns. So for example, one of the patterns you may see is something like this. The pi over 4s always end up with the 5s. So pi over 4 is 45 degrees. 3 pi over 4 is 135 degrees. 5 pi over 4 is 225 degrees. And then 7 pi over 4 is 315 degrees. So you can see that all the 4s end up with 5s. The 6 and the 3s are harder to remember, and so if you are just trying to fill out the unit circle as fast as possible, what I would suggest is that you look for some patterns. Okay, so first you start with the 4s. You can see that this is, let me change this to red. This is pi over 4, so think of it as 1 pi over 4. Pi over 2 is really just 2 pi over 4, because pi over 4 plus pi over 4 is going to be 2 pi over 4, which reduces to pi over 2. And then after that, 3 pi over 4. So you can see it goes 1 pi over 4, 2 pi over 4, 3 pi over 4. And then 4 pi over 4 turns out to be pi. 5 pi over 4. 6 pi over 4 turns out to be 3 pi over 2. 7 pi over 4. So if you want, you can see that the 4s all go up by 2s. So 1 pi over 4, 3 pi over 4, 5 pi over 4, 7 pi over 4. So it goes 1, 3, 5, 7, the odd numbers. The 6s are a little bit harder to remember because the way it is. I am not quite sure how you want to remember it. You can remember it like this. This is pi over 3, 2 pi over 3, 3 pi over 3 gets you to pi, and then 4 pi over 3, 5 pi over 3, and then 6 pi over 3 gets you to 2 pi. And then the leftover ones are the 6s, and the way I remember it is that they're always just a little bit higher than the 0, or a little bit close to the 180. So a little bit higher than the 0 means it's just pi over 6. A little bit less than pi is 5 pi over 6. This is a little bit more than pi, so 7 pi over 6. And the last one is a little bit less than 2 pi, so 11 pi over 6. Okay, if this is very crazy and you cannot remember this way, then what you want to do is just force yourself to remember which numbers link with which ones, and you want to just try to find a pattern, because what's going to happen is next week we are going to fill out the entire unit circle with radians, degrees, and their coordinates, and all of that has to happen under 5 minutes, which I believe you can totally do it. You just need more practice. Okay, so okay, obviously, we're not just memorizing these unit circles for fun. The reason we're memorizing these unit circle is that we want to figure out what is the sine and cosine at each value, each angle. Recall that cosine means x, sine means y. Okay, so this is x, this is y. So what that means is if I said something like, what is cosine of pi over 6? What is cosine of pi over 6? What you do is you come over to pi over 6, and then you look at cosine. Cosine is x, so that is this position, which it tells us is pi square root 3 over 2. So square root 3 over 2 is the answer, and that's how we use the unit circle. So let's try another one. You can use your unit circle to double check. What is sine of, let's say, let's try something that's not actually on here. Okay, let's try sine of 3 pi over 4. 3 pi over 4. So what you want to do is come over to 3 pi over 4. Okay, come over to 3 pi over 4 and then look at sine. Sine, remember, is the y coordinate. So you look at the y coordinate here. It's not written here, but in your unit circle, it should say 1/2. So sine of 3 pi over 4 is it's not 1/2. It should be square root 2 over 2. Okay, so sine of 3 pi over 4 is square root 2 over 2. So eventually, we want to get to the point where if someone just tells you a sine of 210 degrees, you should be able to tell them what value that is. Okay, but we'll get there. Okay, so the only last thing we need to go over is the second part of today's lesson is about intercepted arc, which is just talking about the length of the arc. So, for example, if you have this circle that's like a pizza, and you get this slice. Intercepted arc, or length of arc, or arc length, is really just asking you how long is the crust? How long is the crust on this piece of pizza that you got? And it's very easy because there is a formula. So the length of the arc, we call that S, is equal to r theta. R means the radius of the circle, and then theta is the angle, but this is a little bit tricky. The angle has to be in radian. Okay, if you do this in degrees, it will not work. So the angle has to be in radian. Let's write it here so we don't forget. The angle has to be in radian. So let's look at this question. Find arc length ABC to the nearest tenth. All right, so let's take a look at A. So the arc length by formula is, is S equals r theta. So looking at that circle, what is r? R is the radius, so that is 12. Theta means the angle. The angle of that slice that has length A is 60 degrees. Now, is it okay if I put it in 60 degrees? No. We have to change this to radian. So we have to multiply by pi over 180, just like we talked about a few minutes ago. And then at this point, you want to just multiply it all together. I'm going to try to simplify as much as I can before I use my calculator. So this is 12 pi over 3. And then that cancels. We get 4 pi. And at this point, you should just use your calculator to figure out what that number is. And this number is 12.6, round to the nearest tenth. Okay, so let's have you try B and C. So B is this one and C is this one. So figure out what the arc length is and then come back and check your answer. Okay, here are the answers of the arc lengths. B is 25.1, and that is because B is the leftover basically the B angle here is 120 degrees. And then so kind of find the arc length that way. And C is going to be half of a circle, so that is 180 degrees or pi, and then you find it that way. Okay, so you can go ahead and try these. It doesn't seem very clear what they want you to find. So let's say number 2, they want you to find AC, and then number 1, they want you to find S. So go ahead and pause the video, check your, try it, and then come back and check your answer. All right, did you get these answers correctly? Number 1 is 10, and number 2 is 25.6. Please remember to change it to radian. And you need to be able to find the pi button on your calculator.